Hello students, welcome back to classes on computer organization. In this video, let us see about the direct mapping technique. So mapping is the one where to copy the content from primary memory to cache. It is the process of mapping, or it is process of transferring the block of data or amount of data from primary memory or RAM to cache. The size of RAM, as we have discussed earlier, the size of RAM or primary memory is larger compared to size of cache. So entire amount of primary memory cannot be placed at a time on the cache. Only certain part, only certain amount of data can be placed. So you have to go for replacement algorithms as well on the cache. Replacement in the sense deletion and adding a new one, right? So direct mapping, in direct mapping technique, just go through the diagram. So we are assuming the primary memory with the block 4096 blocks, 4096 or 4k. Okay, the size of primary memory we are assuming it as 4k. What is k? K means 1024 bytes, right? So 1024 into 4, you will get 4096. Starting address of the block is 0, so the last address will be 4095, as you can see. That is what the primary memory is, and size of cache is what? Only 128 blocks. 4096 blocks are there on primary memory as per this diagram, and only 128 blocks are available on cache. So recently you have to follow the principle of locality, temporal and spatial. That is, recently executed data should be placed on cache, and as well as should be placed on cache because it is there is a probability of calling the same data again in near future. And the data relevant to recently executed data should also be placed on cache as per spatial locality. So block 0 to block 127 are the 128 different blocks available on cache as per this diagram. It will be having a tag as well for additional information. Okay, so there is a rule. As per direct mapping, there is a rule you have to follow. What is the rule you have to follow? See, you have to follow the rule of Jmod 128, because mod 128, because of what? There are only 128 blocks available on cache. Whatever the number from primary memory, it should be mapped onto one among these 128 blocks. That's why you have to follow that strategy, Jmod 128. Okay, so block J of main memory maps onto the Jmod 128 block of cache as per this explanation, right? So, so it is not letting me to write the content over here. Please try to understand. uh, J mod 128, what is the mod operation? Modulo division, right? So 11 mod 10, what is the answer? Remainder is the answer. 11 mod 10, percentage symbol is used, no, for modulo operation. So what is 11 modulo 10? 11 divided by 10, you have to access the remainder. So 11 divided by 10, remainder is 1, right? So J modulo 128, answer is 11 modulo 128. Sorry, whatever the number modulo 128. So remainder or till 127, remainder will be, if numerator is smaller than denominator, numerator itself is the remainder value, and if numerator and denominator values are equal, then 0 is the remainder. If numerator is greater than denominator, then you will know how to calculate the remainder, right? So uh, when the memory block 0, 128 and 256 are loaded into cache, block is stored in 0, because 0 modulo 128 is 0, 128 modulo 128 is 0, 256 modulo 128. See, 256 modulo 128, 256 is to be divided by 128. What is the quotient? 2 into 2, right? Into 2, 250, 128 into 2 is 256. What is the remainder? Remainder is 0, right? It should be mapped onto 0th block. That's it. Similarly, block 1. So block 1, where to map block 1 of primary memory? You substitute in the formula 1 modulo 128. What is 1 modulo 128? As I told you earlier, if numerator is smaller than denominator, numerator itself is the remainder value. So 1 is the remainder value. What is 129 mod 128? 129 mod 128. See, denominator is smaller, right? Numerator is larger. You follow the steps. Divide number 129 by 128. 128 ones are 128. What is the remainder? 1 is the remainder. Similarly, 257, if you divide by 128, 128 into 2, 256. So what is the remainder? 1 is the remainder. So they should be mapped onto block 1 of cache, right? So the contention may arise when cache is full, as well as you have to go for off. Obviously, if the cache is full, you have to follow the replacement algorithm. We will be discussing about replacement LRU and MRU. There are two strategies we have least recently used and most recently used. In majority of cases, LRU algorithm is used. Okay, when more than one memory block is mapped onto the given cache block position. So this contention is solved by allowing the new blocks to overwrite the currently resident block. That's it, right? If the cache is full, then the contents will be overwritten. Okay, please remember that. And it has got a tag field. So main memory address of the direct mapped cache will be, it will be having a 16-bit address. That 16-bit, out of 16 bits is divided into 3 columns. So first 5 bits right from MSB, 5 bits which represents the cache address. Cache address, the block address of the cache, which is marked as tag. Then block address of the 7 bits, next 7 bits represents the block address of the primary memory. So block address of the primary memory is marked as block itself, and word address in a block, there are 4 bits are used. Please remember, a block is a set of word. So each block may contain any number of words. So word addressing, again 4 bits are reserved each in each block to represent word address. Okay, further we have byte addressing also, but it is not required here. Please try to understand. It uses 16 bits primary memory address, main memory address. So direct mapped cache which uses 16 bits main memory address. That 16 bit, how it is divided, right from MSB, 5 bits which represents the tag is the cache memory address. Then next 7 bits represents the block stands for primary memory address, right, block address. And further each block may contain any number of words, so next 4 bits reserved for word addressing, right? Same thing is explained here. Please go through the explanation. Okay, lower order 4 bits, 7 bits, then finally higher order 5 bits, right? That is about the direct mapped cache. So in the next video, let us discuss about the associative mapped cache. Okay.